Okay, so now that we understand Mendel's basic laws, which were segregation and independent assortment, now we can talk about how they connect with probability and how we use tools like the Punnett squares to predict genetic outcomes. So first, we make some assumptions when we're using the Punnett square. So one is we're assuming that each gamete, again our sperm or egg, contain just one allele per gene. We also assume that all combinations of alleles are possible across gametes, which brings in the law of independent assortment. And importantly, we assume that the male and female gametes combine randomly. So now we can talk about some probability math. So the rule of multiplication says that to find the probability of two independent events happening together, you must multiply their individual probabilities. So a classic example is flipping a coin. When you flip a coin, there's a half chance of getting tails and a half chance of getting heads. If we flip two coins in a row, the chance of getting two tails is 1/2 times 1/2, which is equal to 1/4. So genetics works the same way. If the chance of inheriting one recessive allele is 1/2, and the chance of getting the same from the other parent is also 1/2, then the odds of ending up homozygous recessive is 1/4. So let's scale this up to humans. We have 23 pairs of homologous chromosomes, and every pair behaves according to Mendel's laws during meiosis, the cell division process that makes gametes. So each pair of chromosomes and the alleles they carry separates independently. So when sperm or egg are formed, they contain random combinations of chromosomes and alleles. So again, that's why there's so much variation in offspring and even among siblings. So how do we apply this knowledge to real families? So that's where a pedigree is going to come in, which is basically a family tree that's going to track inheritance of a specific trait or genetic condition. So on these charts, males are going to be represented as squares, females are represented as circles. If these shapes are shaded in, that means the individual is expressing that trait. Often that trait is some sort of genetic disorder. A horizontal line connecting two people means that they're a couple, and vertical lines are going to show their children. So here is an example of a pedigree over here. So circles represent a female, and then the squares represent a male, and then the horizontal line, a union. So if we look down at the vertical line, this is going to show you their children. So this is one child they had. This is another child they had, and this child married this male, and this child married this male, and they went on to have other children themselves. So you won't be tested on an exam to determine what the genotypes necessarily are, but you should understand what a pedigree represents: the circles, the squares, the inheritance, the horizontal lines, and the vertical lines. So there are some examples of autosomal disorders, and these are going to be caused by genes found on non-sex chromosomes, and those non-sex chromosomes are called autosomes. So in an autosomal recessive disorder, a child can be affected even if neither parent shows symptoms. So as long as both parents are carriers. These parents each carry one recessive allele, and if a child inherits both, they're going to express the disorder. So genetic testing can help people find out if they're carriers before deciding to have kids. On the flip side, you can have autosomal dominant disorders, and these work differently. So just one copy of the dominant allele is enough to cause a disorder. And interestingly, even if both parents are affected, it's possible for some of their children to be unaffected if they inherit two recessive alleles. The way that would be possible is if the parents were both heterozygous for the trait. But if both parents are unaffected, there's no dominant gene to pass on, so all of the children will be fine.